Alright, pre-algebra, we are getting into some geometry now, starting with triangles. This is the lesson in chapter 10, then we're going to jump to chapter 11 with some more geometry lessons. So triangles first, lots to be reviewed, but there's a couple important things we need to talk about to make sure we know. So quickly, or not quickly, but pause the video, write down the highlighted terms. In a triangle, a line segment is a part of a line. Okay, so a line goes on forever in two directions. A line segment stops at two endpoints, so it terminates or ends. A triangle is formed by three line segments. So these line segments are actually called the sides of a triangle. And a vertex is the point where line segments meet. So there's also three vertices or three vertexes in each triangle. Those are the corners where the angles are formed. So the sides are line segments. The angles and corners are vertices, vertexes. This rule down here, very, 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 very important. You use this a lot. I teach geometry to you in a couple of years. Probably one of the most important rules we talk about. The three angles of a triangle, the interior angles will add up to 180 degrees every time. Alright? In geometry, we discover why this is true. For now, we're going to take it as truth and use this rule. X, Y, Z, those three angles will add up to 180 degrees every time. So, how can we use this? If I look at this triangle and this problem right here, I know two angles in a triangle. I don't know the third. But because I know that they add up to 180, I can figure this angle out. So if I add up the three angles, it has to equal 180. So angle P, well, I don't know what that is. That's my X. Plus angle Q, or the M means measure. So the measure of angle Q means how many degrees it is. Well, it's 54 degrees. And then angle R is 89. And that has to add up to 180. And now this is just an equation. I need to solve for x. Okay? I can combine these two terms together. Alright? So if I do that, 54 plus 89 gives me 143, according to my mental math. That equals 180. How do I solve this equation? Yeah, I gotta get rid of this 143 to get x by itself. So I subtract 143. And again, my mental math tells me x should equal 37. Let's check if I'm right. Good, 37 degrees. You can always double check your answer. Take 37 plus 54 plus 89. Make sure they add up to 180. Now, guided practice, same thing. You know two angles down here. How do I find my third? Well, I add these together, and then I'll subtract them from 180, just like we did up here. This one's a little bit trickier, but we just got done doing ratios. The angle measures of a triangle, ABC, that's just the corners or the vertices of the triangle, are in a ratio of 1 to 3 to 8. Okay? That means the first angle is some number, the second angle is 3 times that number, and then the third angle is 8 times that original number. So we don't know what that number is. Let's say that's x. We did that right there. That first number is x. Well, the second angle is 3 times that number, so I'll put 3x. And then the third angle is 8 times whatever that first angle was, 8x. So again, I just solved this equation. What is 1x plus 3x plus 8x? Well, that's 12x equals 180. How do I solve this equation? I got to get rid of this 12. This is 12 times x. So opposite of multiply is to divide. I divide both sides by 12. X equals 15. So what are my three angles? Well, my first angle is 15. My second angle is 3 times that. 3 times 15 is 45. So 15, 45. And my third angle is whatever 8 times 15 is, which is 120. So those should be my three angles. Let's go ahead and check. Right there. 15, 45, 120. Perfect. Now, here comes some review that we'll go through quickly because I know you've had this before, but you should still write these down. Acute angle is an angle less than 90. Right angle is a 90-degree angle. Obtuse angle has to be between 90 and 180. So basically more than 90, but we can't go past 180. And then a straight angle makes it a straight line, which is 180 degrees. Alright, so really simple question here. They had this old saber-toothed cat that lived 11,000 years ago, had jaws that could open to an angle of 120 degrees. What kind of angle is that? Well, 120 degrees is greater than 90, and it's also less than 180, so that means it's an obtuse angle. If you look at the guided practice while I'm writing this, they have a lion that can open at a 65-degree angle. What would that be? Well, that would be acute, because it's less than 90. Now, we classify triangles in two ways. They can be an acute, obtuse, or right triangle because of their angles, and we can also classify them by their sides also. So let's look at the angles first. An acute triangle has all acute angles. Look here, 3 angles that are all acute. All right. An obtuse triangle has just one obtuse angle. We can't have more than one, because if we have 2 angles more than 90, we're over 180 degrees, and we can't have a negative angle. So we can only have one obtuse angle. If it has one, it's called obtuse, and it has one right angle, then it's a right triangle. So just like this, one right angle. Same thing, we only have one. If we had 2, then we'd have 2 degrees. Now, the sides would be scalene, isosceles, and equilateral. Scalene means there's no congruent sides. Isosceles means it has at least 2 congruent sides. And equilateral, equal means they're all equal, so all sides are congruent. Congruent means equal or same length. Alright, so we can classify them 2 ways here. We can have this is an acute scalene triangle. If all the angles are different, or all the angles are acute and all the sides are different, we could have obtuse, isosceles, we can have all sorts of different ones. Alright, so let's look at some possibilities here as examples, and then we are done. Classify this triangle by its angles and by its sides, both ways. So I look at the angles first. 40, 50, 90. Well, I have a right angle. One right angle tells me this is a right triangle. Now I look at the sides. Do any of the sides look like they're the same, or are they marked the same? No, they all look a little bit different. So that'd be scalene. So this would be a right scalene triangle. B. If I look here, acute, acute, acute. So this is an acute triangle. All 3 angles are acute. Now these dashes mean the sides are congruent. So that's telling me if they put those dashes there, like that and that, that's telling me those sides are equal. So I have at least 1 pair, 2 sides that are congruent. That tells me it's an isosceles triangle. So I combine those 2 together. It's an acute isosceles triangle. And quickly guided practice, I'll go through it fast. I have 3 angles that are all acute. All the sides are different, they're not marked, so it'd be acute scalene. And then over here I have all the angles are equal, or all acute, and all the sides are equal. This would be an equilateral triangle. You could say acute equilateral, but equilateral implies that they're all acute. Okay, that's all there is today. Have a wonderful, wonderful day. I gotta get a shout out to the Wills. I said I'd do it last time. The Wills get the shout out today.